Hey everyone, I'm Anam and today's video is about the galvanic or voltaic cell. Let's start with the electrochemical cells. Electrochemical cells are of two types, galvanic or voltaic cell, and the other one is electrolytic cell. When we talks about the electrolytic cells are those cells in which chemical reaction does not occur on its own and it requires external agent just like electricity. And if we talk about the galvanic cells are those type of cells in which chemical reaction start on its own, or we can say that galvanic or voltaic cell are those type of electrochemical cells in which spontaneous reaction take place and electricity is produced. Okay, the best example of galvanic or voltaic cell is the tandem cell. Let's talk about the construction of galvanic or voltaic cell. Basically, it consists of two cells, one half cell and other half cell. One half cell is called the left half cell and the right half cell. Okay, and these two half cells are connected electrically by a salt bridge. Okay, two half cells which are electrically combined with salt bridge. If it talks about the salt bridge is of U-shaped glass tube in which saturated electrolyte is present, and the purpose of that electrolyte is to keep the cells neutral by providing pathway for the migration of ions so that the chemical reaction take place. Okay, let's talk about this, or we can say let's talk about the working of the galvanic or voltaic cell. Okay, basically if it talks about this side of the half cell, there is an electrolyte, okay, of zinc metal which is dipped in a solution of its own salt. Just like if it is zinc, it is dipped in 1 molar solution of zinc sulfate. If it talks about the other half cell, it also contains an electrolyte, but that is made up of copper metal. And it is also dipped in 1 molar solution of its own salt, copper sulfate. Basically, there are two half cells. One half cell contains an electrolyte of zinc metal which is dipped in its own salt, that is zinc sulfate. 1 molar solution of zinc sulfate. If we talk about this half cell, it also contains electrolyte of copper metal which is dipped in 1 molar solution of copper sulfate. And there is a wire which connects these two electrodes. There is a voltmeter as electricity is produced, so we use voltmeter to check. Okay, and there is another thing, that is a salt bridge which is just connecting these two cells to provide the pathway for the migration of ion so that these two solution remains neutral. Okay, let's start. When we just connect these two electrodes with the external wire, and when we then the chemical reaction take place, spontaneous chemical reaction starts. Okay, it talks about the zinc and the copper. Zinc can easily lose its electrons and copper can accept those electrons. So when the chemical reaction starts, zinc loses 2 electrons and zinc changes into zinc ion and dissolved in the solution. Okay, when zinc loses 2 electrons, because zinc have tendency to lose the electrons, so zinc easily lose 2 electrons and zinc changes. This is the zinc atom which have no charge. When it releases or it loses 2 electrons, it is converted into ion. Okay, and that zinc metal when changes into ion dissolved in the water, and these 2 electrons move through the external wire towards the cathode. Here is the anode and there is the cathode. If it talks about the redox reactions, redox reactions. Redox reactions are those type of reactions in which oxidation and reduction reactions take place. Let's talk about the oxidation. Oxidation is such type of reactions in which there is addition of oxygen. Okay, addition of oxygen, removal of electron and removal of hydrogen. But if we talk about the reduction which take place here, there is gain of electron, gain of hydrogen ion and lose of oxygen. Okay, when we talk about this part, zinc loses 2 electrons and loss of electron is called the oxidation. So we can say that at this cell, at the anode, oxidation takes place because zinc loses 2 electrons. And copper here receive these 2 electrons and become copper and deposited here. As it received 2 electrons, the gain of electron is called the reduction. So at cathode, reduction takes place. Again, zinc loses 2 electrons. Loss of electron is called oxidation. These 2 electrons moves toward the cathode, and at cathode, these copper ions have tendency to gain these 2 electrons, and these copper ions receive these 2 electrons and become copper and deposited at the metal plate. As they gain electron, gain of electron is called the reduction. Okay. Next, here is a salt bridge which provide pathway for the migration of ions so that both these solutions become neutral. Okay, let's talk about the redox reaction here. Zinc loses 2 electrons and become zinc ion here and dissolve in the water. Oxidation takes place at the anode. And we talks about the second half cell. At cathode, copper ion receives 2 electrons. Copper ion receives 2 electrons and become copper and deposited at the metal plate. Become copper. We talks about the overall reaction. Redox reaction. Okay. RE D and OX. Redox reaction. Overall redox reaction. Zinc, copper. And at the end, if we just cancel the electrons, okay? At the end, we have zinc ion and copper. It's all about the galvanic or voltaic cell. Thank you.